Bismillahirrahmanirrahim. Okay, we are still in chapter 4, Resonant Circuits examples. So let's see some examples of question and solutions for this chapter. First, example 1. In the circuit below, given R equal to 2 ohm, L equal to 1 millihenry, and C equal to 0.4. A. Find the resonant frequency omega naught and half power frequencies omega 1 and omega 2. B. Calculate the quality factor Q and B. Bandwidth. C. Determine the amplitude of the current, the I at omega naught, omega 1 and omega 2. Okay, given this is the circuit. Simple series RLC circuit with 20 sin omega t power supply. Solution. A. The resonant frequency omega naught can be calculated using this formula 1 over cert LC. So we put the value of L 1 milli Henry and C is 0.4 microfarad. So solving this, we can have 50 kilo radian per second as omega naught. So using first method, we calculate using the long equation for omega 1 and omega 2. So putting all this value R to 2L, putting all this value, solving this equation, we get 49 kilo radian per second for omega 1. So using the same formula, but this value become positive, we calculate for omega 2. So we have this 51 kilo radian per second. So omega 1 is 49 and omega 2 is 51 kilo radian per second. So bandwidth is omega 2 minus omega 1, which is 51 minus 49, which is so we have 2 kilo radian per second as the bandwidth. Or we can also using the equation B equal to R over L for calculating the bandwidth. So solving this equation, we also have the value of 2 kilo radian per second for bandwidth. Q, what is the value of Q? We can use the definition or the equation of the definition of the quality factor, which is resonant frequency over bandwidth, which is the resonant frequency 50 kilo radian and bandwidth also 2 kilo radian. So 50 over 2, the same unit, is 25. So Q is 25. So I, what is I? I is V over R. Given V is 20 and R is 2. So at omega naught, the maximum current is 20 over 2, which is 10 ampere, and at half power frequency omega 1 and omega 2, the value of current is the same. We can use the equation or cert2 multiplied by this value, or we have Vm over cert2 R. So 10 over cert2 is 7.071 ampere. So this is the amplitude of the current at half power, and this is the amplitude of the current at resonant frequency. Okay, so this example is the same as previous example. It show in one page only. So in the circuit, same circuit, find the resonant frequency, find the half power frequency, calculate the quality factor Q, calculate the bandwidth, determine the amplitude of the current. So A, resonant frequency, using this equation, 50 kiloradian per second. B, Q, this is using the approximation equation. So Q, given since Q is more than 10, is larger than 10, so we calculate the Q, omega naught L over R equal to 25. So this Q value is more than 10. We can use the approximation equation, which is omega naught minus B over 2 for omega 1, and omega 2 is omega naught plus B over 2. So minus, so 50 minus 1, 49, 50 plus 1 is 51. The bandwidth is using this equation, 50 over 25, we can have 2 kiloradian per second. And to calculate the value at omega naught, omega 1, and the value of current at omega naught, omega 1, and omega 2, you can use this equation, I V over R for omega naught, and Vm over sub 2 R for omega 1 and omega 2, the current at omega 1 and omega 2. So the solution, the answer is same, using method 1 or method 2 for this one. Okay, next, for the given circuit, determine the resonant frequency, voltage across each element at resonance, and value of Q. So given this circuit, supply voltage is 10, R is 2 ohm, L is 25 millihenry, and C is 10 microfarad. So A, resonant frequency, we can use this equation, omega naught equal to 1 over LC. We get 2 kiloradian per second, or 20 or 2000 radian per second. 2, voltage across each element. So at resonant frequency, I equal to V over Z equal to V over R equal to 10 over 2, which is 10 is the voltage, 2 is the resistance. So the current is 5 angle 0 ampere. So VR is IR. So I multiplied by R. I 5 multiplied by R, 2 ohm, 10 volt. VL is I multiplied by ZL, which is J omega L. J omega, we have this value, omega. L is 25 millihenry, this one, and I is the value here, I 5 ampere. So solving this equation, we get 250 with angle 90 degree. For voltage of the capacitance voltage, the voltage here, I multiplied by Z, the impedance of capacitance, which is 1 over J omega naught C. So we have the value of I, 5 ampere, 1 over J omega naught, we have here 2000, and C, we have the value here 10 microfarad. So solving this, we will get 250 volt with the angle minus 90 degree. So Q, the value of quality factor, Q, what is the equation? Q is omega naught L over R. Omega naught 2000, L 25 millihenry, over R. R is 2. Solving this equation, we'll have the value of Q is 25. Next, for the given circuit, calculate the value of C that will produce quality factor of 50. This circuit, calculate the value of C given that Q is 50. Find omega 1, omega 2 and B, the bandwidth. C, determine the average power dissipated at omega 0, omega 1 and omega 2. Okay, solution A, Q. Q is given as the value of 50. So solving, putting all those given value, we have Q 50, omega 0, L is 25 millihenry, R is 4 ohm. Solving this equation, we will get the value of omega 0 as 8000 radian per second, or 8 kilo radian per second, omega 0. So when we get the value of omega 0, we can use this equation, the relationship between Q, omega 0 and C and R, to calculate the value of C. So rearrange this equation and putting the value, we get C equal to 0.625 microfarad. Okay. B, find omega 1, omega 2 and B. So B, the bandwidth is omega 0 over Q. Omega 0 is 8000. Q is given as 50. So 8000 over 50 equal to 160 radian per second. The bandwidth is 160 radian per second. Since Q is more than 10, the value of Q given 50, so it is more than 10, we can use this equation, approximation equation. Omega 1 equivalent to omega 0 minus B over 2, and omega 2 is omega 0 plus B over 2. So solving this equation, we will have omega 1 as 7920 kilo radian, and omega 2 is 80 kilo radian. So we solve B. So average power C, the average power is half I square R. The average power is half I square R. At resonant, when I equal to Vm over R, at resonant here, Vm over I is Vm over R, this Vm over R. So half power, half of this, half I square R. So solving this equation, we have Vm square over R. So putting the value 100 square over 4, this one we will have 1.25 kilowatt average power at omega 0. So the average power at omega 1 and omega 2, which is half power, is this value, this power at omega 0 divided by 2. So the power at half power is, the power at omega 1 and omega 2 is 0.625 kilowatt ish. Here 0.625, and here also at 0.625. That's all. Thank you very much.